Let's create some large water droplets. I'll copy and paste the bottle geometry. Let's rename this to large droplets. Turn off the liquid cap and text. Space G to frame up. And what we're going to do now is we're going to paint in where our water trails would be. So if I go to the background color, it's currently set to black. Let's apply that to all so it looks like this. And we'll change the foreground color to red, so 1, 0, and 0. So red, green, blue. And the brush should pop up in the viewport. And if that doesn't pop up, click enter on the keyboard when you're sort of hovering in this view. And the brush will pop up, and then you can hold down shift and left click and drag to reduce the brush size. We'll go to the brush tab and we'll decrease the opacity to something like 0.1. And then what we can do is just start painting in, maybe even drop that right down even more. We start painting in sort of where these trails would go. And I'm being really expressive and quite random with this. I'm not being too accurate. I'm just sort of following those trails all the way down to the bottom. Have some larger sections where it's a bit thicker. There's more drops. Cool, so something like that I think works fine. And if you need to take out some red, you can just go back to the foreground, change that to 0, and you can just paint in where you don't want it. Just like that, for example. Okay, so what we want to do now is we want to scatter a lot of points. So we'll drop down a scatter sop, and we want to scatter a lot of points based on that red color information. So if we click on the facet, middle click on it as well, and you'll notice there are 2 point attributes. There are normal and position attributes. If we come down to the paint sop, we now have a color attribute, which is sort of represented as capital C and then a D. So if we go down to the scatter sop, let's tick on this density attribute, and currently it's set to density, and we don't have a density attribute. It's non-existent, but we do have a color attribute, so we can put capital C and D, and now we've scattered points based on the red channel, which is what we painted. I'll come down, I'll turn off relax iterations. I usually do this, which randomizes the sort of point order. And from this point, I'll take a copy to points sop. And the right input says target points to copy to, and the left input is our primitives. So what we're going to do is we're going to copy spheres onto these points. So we'll plug that in. We'll create a sphere. We'll change that sphere to a polygon mesh. Currently the sphere is 1 meter in size, which is way too large. We'll hook that up, we'll view it. So now we've got 1,000 points and essentially 1,000 spheres copied. Let's change this to 350. And we still need to change the size of the spheres. So there's 2 ways we can do this, and I'm going to show you the way that I wouldn't usually do. I could reduce this to something like this, and now we've got spheres all the same size as this, copy to each of the points. And that's not very random, and we want spheres with different sizes. So I'm going to turn that back to 1, and instead of defining the scale of the sphere here, we're going to we're going to change the P scale using a attribute randomize SOP. So I'll plug that in. And what I'll do here is I'll change the attribute name to P scale because we want to change the scale of the spheres. So P scale. And then we can specify in here something like 0.0002, which is the minimum size of every sphere. And we need to define the maximum size a sphere can get. So I found that a value of 0.0027 worked for me quite well. I'll just copy that over to the other channels. Just like that. So if I view our water droplets, we now have spheres ranging between this value and this value. So the smallest sphere is this size and the largest sphere is this size. So let's continue and we'll add even more sort of randomness. On this sphere, we will add a mountain SOP just to randomize and distort the surface of the object a little bit more. I found that something like a value of 1.74 and 7.28 work quite well for me. Something like that. So just to switch between the two of them. It's just got a little bit more random. So let's view, let's see what that looks like. So we got some more blobby type spheres there, which aren't so linear. And then on top of this, I think I'll just scale this sphere in Y just a little bit to make it a little bit more elongated. Something like 0.63, something like that. And then we'll view it. So we've got this kind of thing happening, which looks really cool. The next thing I'll do is if we middle mouse click on this copy to point SOP, you'll notice we've got 100,000 polygons, which is a fair amount. So what we can do is turn on this pack and instance, and now we have 350 primitives. Let's take a VDB from polygons SOP, and we're going to sort of approximate the size of each of these spheres to get even more randomness. And this is the stage that makes these water droplets look a lot more realistic. So that was a setting that worked for me quite well. And just have a slide around with this and see what you get. After this, I drop down a convert VDB. And we want to convert this VDB to polygons. So we were at polygons here. We converted this to a VDB, sort of approximated the size of each of these spheres to give more randomness. And now we're converting this VDB back to polygons. So convert to polygons. And that gives us a much more organic and realistic shape. So from this stage, if we click W on the keyboard, we can see the wireframe and it's looking a little bit too primitive. So let's subdivide it just by one level. So I'll just bypass this so you can see it. And that's looking pretty cool. Okay, so we'll just leave it there for now. And one thing I'm going to show you is if we zoom in between the bottle, you'll notice that we've got the water droplets are sort of going through the outside wall, which is bad. That's going to cause a problem later in rendering. So we need to remove the water from the inside. So what we're going to do is jump back into the large water droplets. We're going to view from the transform here. I'm going to drop down and edit, just like that. So we can select the polygons here. I'll click S on the keyboard to go into selection mode. And I'm just going to select the outside surface. So we need to isolate the outside surface. So what I'll do is I'll select this entire ring around here, all the way around. Just like that. So I'm shift clicking to select the faces, control click to remove. And I'm just going to hit delete. And that will delete those faces and put them in a blast SOP, which is similar to a delete SOP. And then what I can do is double click on, or click S again on the keyboard, double click on this inside shell, hit delete. So now we have just the outside shell. From this point, I'll drop down a subdivide SOP. We'll increase the depth to 2. We'll add another facet, or just copy and paste it really. It's fine. Like that, to post-compute the normals. And we'll take a Boolean SOP. We'll drop it down. And what we want to do is we want to Boolean these water droplets by this outer shell. So we'll plug the outer shell into the right input, so geometry B, and we'll plug the water droplets into A. If we view from here, we'll see we get this. So that's not looking right. So what we do is we treat A as a surface, just like that. We treat B as a solid, and now we just say subtract. So now we've got our water droplets on the outside, and they're booleaned by the outer shell, so you can see they're not penetrating through the surface anymore. After this, I'll add a subdivide SOP again, just like that. And I'll drop down a facet to recompute those normals. So right now, we can compute those. So now we have our nice large water droplets, which are looking nice and randomized. So let's view those. And they're looking pretty damn cool. I'll do a file save as.